Hey Year 7s, and welcome to our next video tutorial, exercise 9G. And I know I keep saying I need to change my intro. I will eventually, but not right now. Exercise 9G, here we are looking at symmetry. Okay, symmetry. Being symmetrical. You see in many try and say that 10 times really fast, geometrical shapes in nature. Okay, so as you can see here, a starfish and a sunflower are two examples, and there'd be hundreds, thousands, millions of examples in everyday life that you see in nature. Shapes such as these have there's two types of symmetry. There's both a line symmetry and a rotational symmetry. Okay, so they're a little bit different. They both sort of work similar, but a little bit different. So let's have a look at them. So an axis or line of symmetry divides a shape into two equal parts. Okay, so as you can see, our triangle here, it's an isosceles triangle. A line going down the middle, and it acts as a mirror line. So one side will be reflected exactly the same as the other. And if we could sort of fold that triangle on that line and fold this part over on the other one, whichever way you want to look at it, if we folded it over, it would lie exactly over the other side, like it would be exactly in line. All right, and there's a good little where are we? Hot math little thing here. Which one are we looking at? 9.7 symmetry, lines of symmetry. Go through some examples of this. So if when I get to the end of the video, if you're not still a bit unsure of it, as you can see, so a line of symmetry there means it can fold over. So if we did a line of symmetry this way and tried to fold this side over, it wouldn't fit, it wouldn't match. Okay. So yeah, that's line of symmetry. So another example here, you could do it that way, folds over, matches up. So let's look at the end. So if we did a line of symmetry that way, doesn't match. So there's no line of symmetry on that way. So what if we tried the other way? A line that way, fold it over, again, doesn't match up. Okay, so this shape doesn't have any axes or lines of symmetry. Again, doesn't match up if it does it on the angle. Okay, so there's no axes or lines of symmetry on all shapes. Okay, so only on some shapes. And this is maybe another example here. So, yep, fold it over, doesn't match up, it's a bit skew-if. Okay, we go through this other way. Again, fold it over, skew-if, doesn't match up exactly. So it doesn't have no axes or no lines of symmetry on this shape. Okay, same if you do diagonals. All right, so that might be a good one to have a look at if you're confused by lines of symmetry, and you've got a few little resources in terms of little activities you can look at there to try and reinforce your understanding. So that is a line of symmetry. Okay, the order of line of symmetry is the number of axes of symmetry. Okay, so now the order of rotation is the number of times a shape makes an exact copy of itself after rotating 360 degrees. We might have another look. Yeah, so maybe this one. Whoops, don't want to do that. So if we look at the triangle, for example, okay, there's 1, 2, hasn't gone around yet, watch the arrow, that's 360 degrees, so it's got 3. So this triangular shape repeats itself 3 times in a 360 degree turn, so it has rotational symmetry of order 3. Let's have a look at this S. So, yep, there's 1 and there's 2. Okay, so the letter S repeats itself twice in a 360 degree turn, so it has a rotational symmetry of order 2. And it also has a point, no, I won't worry about that one. Okay, so it's got rotational symmetry of order 2. Look at this shape, again, this is where we started, so as we turn around, let's turn 2, 3, 4, 5, and we'll go around to 6. Okay, so it's got an order of 6 rotational symmetry. Okay, if you look at the T, not until we get back to the start. So it has one turn, so because it only has a one turn, it only repeats itself once in an entire 360 degree turn, we say it doesn't have a rotational symmetry. Okay, so that's rotation of symmetry. In the order of rotation is the number of times it repeats itself as you turn it around 360 degrees. Okay, so as you saw with that letter T, we say there is no rotational symmetry if the order of rotational symmetry is equal to 1, which you just saw in that letter T. Okay, hopefully that makes sense to you. Okay, so give the order of line of symmetry and rotational symmetry for each of these shapes. Okay, so basically the line of symmetry, if we did one, that should be down the middle, mind you, and if we folded this guy over, it would match up exactly. And same that way, that should be right through the middle. So if we folded this part over on top of that, it would match up exactly. So there'd be 2. Now if we rotated this guy, how many times would it repeat? So if we rotated it around once and we got it that way, it's not repeating that way, is it? That would be like a 90-degree turn. If we rotate it again, it would go back to the original, same type of shape. So it'd be once, and then rotate it around would be twice. So it would have an order of 2 in rotational symmetry. Okay, let's just quickly check our answers. Make sure I'm not lying to you. Where are we? Geez, oh, there we go. Yep, so there you go. Line symmetry, order of 2. Okay, and rotational symmetry, order of 2. Okay, so that's what we've got there. Okay, hopefully that sort of makes sense. It's sort of a bit hard to sort of explain that. Again, not that. This sort of explains it pretty well. So again, I would have a look at that if you're unsure. But yeah, if we rotated that rectangle around, it would, as we got right around this way, there would be 1, and then we have to rotate it all the way around again, would get us to 2, so an order of 2. So order of 2 for line symmetry and order of 2 for rotational symmetry. This guy, well, if we draw a line, so through that point through there, if we folded it over, so sorry, I'm trying to show you with my hand, but obviously you can't see my hand. If you folded this half over on that half, it would match up exactly. All right, and we could do it through that way, so I'm not drawing these really neatly. Draw it through that way, draw it through that way, draw it through that way. Okay, so if I start there, that's 1 line, 2 lines, 3 lines, 4 lines. Hang on, what have I done myself? Yeah, hang on. I'll start at the top. So 1 line there, sorry, 2 lines there, 3 lines there, 4 lines there, 5 lines there. All right, and then we're back to the lines we've already counted. Okay, so that's got 5 in line symmetry, order of 5 for line symmetry, and also rotating. If we rotated it from there to there, from there to there, whoops, from there to there, there's 1, there's 2, there's 3, there's 4, and we're back to the start, 5. So our rotational symmetry would also be an order of 5. Okay, so line symmetry, order of 5, rotational symmetry, order of 5. Let's have a look. So here's the question here. Go down, line symmetry, order of 5. So you draw the lines that would split into half basically. And rotational symmetry, you rotate it 5 times and you get the same shape every time you did a rotation, and you get an order of 5 there as well. Alright, so hopefully that sort of makes sense to you. I don't know if I explained that one very well, probably not my best effort. I tried though. Have a look at some of these widgets and things on 9.7 Hot Maths Symmetry. I'd work through some of them, check them out. They may help you understand that as well. Maybe have a look at some of these hot sheets. I might set some of them for you anyway. Yeah, but well worth having a look at, but that's how it is. Yeah. All right, thank you guys. Actually, I just saw in the news before, yeah, police caught a couple of kids playing with a car battery and fireworks. Yeah, so they charged one and let the other one off. Yeah, hopefully you got that one. Yeah, a little bit tricky. Think about it. All right, thank you guys. See you later. Bye-bye.